In this video, we are going to discuss about that lithium aluminium hydride versus sodium borohydride. Lithium aluminium hydride, sodium borohydride, they are acting as what reducing agent. That means which reduce the others. Here, lithium aluminium hydride is called as what strong reducing agent. Sodium borohydride is called as what and weak reducing agents. Then what is the differences between these two? Both are reducing agent, but one is the stronger, another one is the weaker. Now this both reduce that what and CO group is converting into an alcohols. This is converting CO group into alcohols. How it is reducing the CO group into alcohol means now there is a CO group is present. This is the CO group. Now these are reducing the others by breaking that what carbon oxygen bond. Here you should add H, you should add H this side. So therefore we are going to get that what an alcohols. CO group is converting into this one. For example, now when we are taking acetaldehyde, C double bond O. Now whenever they given lithium aluminium hydride, it is providing that what hydrogens, hydride ions, that will be what added here. Then we are going to get that what CH3, CH2, OH. Like this the CO group is converting into an alcohol group. Just the CO group you converting into alcohol. Remaining groups are as it is. Next, it is converting acids to alcohols. It is also converting an acid to alcohol. Acid to alcohol. Same. Now when we are taking an acid group, now this is an acid group. Whenever they give an acid and they given lithium aluminium hydride, just you break the bond between carbon and oxygen, add hydrogen. Next what we are going to get R, CH, OH, OH. Two OH groups present on the same carbon. Gem diols are always unstable. Then the elimination of water. Then we are going to get that what R, CH double bond. Again these aldehydes are furtherly undergoing what reduction. Then we are going to get that what alcohols. R, CH2OH. Okay, no? Just you converted, just you remember, see now this acid group is then, this acid group is converting into an alcohol group, that you remember. Whereas here sodium borohydride do not reduce an acid functional group because it is a mild reducing agent. Next the same way here also, esters are converting into alcohols. Esters are converting into alcohols means you break the bond between oxygen and CO group. Now you write here H. Next you break the bond here, C double bond. Here H, here H. Okay, this bond is broken means here H, this side H. Then we are going to get that what R, CH2OH plus R dash OH. Two alcohols are going to be what formed. If it is unsymmetrical alkyl groups are present in that what different alkyl groups are present means different alcohols is formed. Same alkyl groups are present in the ester, will get that what one type of alcohol. Whereas here sodium borohydride also do not reduce that what do not reduce esters to alcohol. Do not reduce esters to alcohols. This sodium borohydride cannot reduce because mild oxidizing agent. Okay. Next I am telling, see now this is an ester. This is an ester. See carefully, see now. This is ester. Now whenever they given lithium aluminium hydride, just you break the bond between CO group and oxygen. Then add this side hydrogen, this side hydrogen. Okay. Next break this CO group. Now here add one hydrogen, here add one hydrogen. Then finally what is having here R, or CH2OH or CH2OH. Next here what is there? R dash OH. Like this you follow simple method, you can get the answers easily. Next, anhydrides to alcohols. Anhydrides to alcohols. Now anhydrides are converting into alcohols by that what? Lithium aluminium hydride. How? Same. What is the simple step? Now this is the anhydride. Now this is the anhydride. Now alcohols are going to be what? Formed. Now you break the bond between this and this. Now here H, here H. Next bond break this between these two. H, H. Next here also break the bond between carbon and oxygen. H, H. Now finally what we are having? R, C, H2, OH. Same here also we are getting R, CH2, OH. Finally we are going to get that what? And this one. Alcohols are going to be what? Formed. That is anhydrides to alcohols. Next, acid chlorides to alcohols. Acid chlorides to alcohol means now when we are taking that what? Acid chloride. See now this is an acid chloride. Next, acid chlorides are, this is acid chloride converting into alcohols. Just you break the bond between carbon and halogen and also break the bond between carbon and oxygen. See now whenever CO group is there, you break that bond compulsory. Now what is the remaining here? R, C, H2, single bond OH, single bond OH plus HCl. We are getting that what? Primary alcohols. This is acid chlorides are converting into alcohols. Whereas this sodium borohydride do not reduce acid chlorides to alcohols. Whereas this sodium borohydride also cannot reduce anhydrides to alcohols. Cannot reduce anhydrides to alcohols. Next, lithium aluminium hydride. It is converting alkyl halides to alkanes. Alkyl halides to alkanes. Whereas this one is do not reduce because it is a mild oxidizing agent. Alkyl halides are converting into alkanes. So now this is an alkyl halide. Now CH3, CH2, Cl, ethyl chloride. Whenever it is reacting with lithium aluminium hydride, then just you converting into what? Alkanes. Here one hydrogen, here one hydrogen. That means reduction. Then what we are going to get? Alkanes plus HCl. Alkyl halides, any alkyl halides are converting into alkanes. Whereas this compound cannot converting aryl halides to benzene. Now this is called as what? Aryl halides. Aryl halides do not undergo reduction. Do not reduce. No reduction. Because here halogen is connected to that what? An sp2 carbon. So therefore here strong bond, partial double bond is present. So therefore this partial double bond cannot be broken by that water, lithium aluminium hydride. So therefore it is not reducing aryl halides. It is reducing only alkyl halides to alkanes. Next, it is converting nitro compounds to amines. Now here removal of oxygen, addition of hydrogens. So therefore we are going to get that what? A reduction. Next, amides are converting into what? And primary amines. See now this is called as what? Amides are converting into amines. by reacting with lithium aluminium hydride. Now how you do that? What simple? Now this is an amides. Now amides, whenever they are reacting with lithium aluminium hydride, you break the bond. Now this side 2 hydrogens, this side 2 hydrogens. That means it is reacting with what? 4 moles of hydrogen. Then what we are going to get? CH2 NH2. Till now in all the cases we are breaking only carbon oxygen pi bond only broken. But in the case of amides, you remember double bond is broken. Then add 2 hydrogens here. Then we'll get a primary amine. Okay. This is amide. Simple steps. Next, cyanides are converting into amines. How we are breaking the bond? Now this is the cyanide. Now you break the bond. Now this side 1 hydrogen, this side 1 hydrogen. Now you break this bond. Now this side 1 hydrogen, this side 1 hydrogen. Now that means this is reacting with lithium aluminium hydride by reacting with 4 moles of hydrogen. Then what we are going to get? What? RCH2 NH2. Then we are going to get that what? And primary amine. This is the simple step. Like this you break the bond. 2 pi bonds only broken. Sigma bond is not broken. With the lithium aluminium hydride, we are adding 4 hydrogens. This is cyanides to amines. Next, azides to amines. This is azide is converting into what? Amine. Next, what about this? This is do not reduce. No reaction. Amides to amines. Sodium borohydride do not give the reaction. Next, cyanides to amines. This is won't give any reaction. Next, both are giving that what? Azides are converting into amines. Azides are converting into amines. Next, last one is both are do not reducing that what? Double bond, triple bond. Carbon carbon double bond, carbon carbon triple bond cannot reducing that what? Both lithium aluminium hydride, sodium borohydride. This is very very important. Next, but reduce the carbon carbon double bond whenever the pH group is attached to beta carbon of the double bond. See now here. Now this is a compound is given. Now this is a functional group. Functional group attached carbon is alpha carbon. The next carbon is called as what? A beta carbon. See now it will reduce the carbon carbon double bond when phenyl group is attached to beta double bonded carbon. It will gives that what? Product. What product it will gives? It will reduce that what? A carbon carbon double bond. In remaining cases, it cannot reduce carbon carbon double bond. Only in this case only it will reduce the carbon carbon double bond. Already we studied aldehydes are converting into alcohols because it is containing CO group. No. Next, reduce the double bond. Now see now here triple bond is there, double bond is there, and aldehyde is there. Now this lithium aluminium hydride, sodium borohydride cannot reduce that what? A carbon carbon triple bond and carbon carbon double bond, but it can reduce that what? Aldehydes to what? Alcohols. Aldehydes to primary alcohols, ketones to secondary alcohols. Okay, now this is. Next one is this is also do not reduce carbon carbon double bond or triple bond, but sodium borohydride combination with platinum chloride, it can reduce carbon carbon double bonds to it can reduce carbon carbon double bond. That means alkanes are converting into alkanes. Now sodium borohydride in the presence of aluminium chloride, in the presence of what? Diglyme, it reduces carbon carbon double bond as well as ester to alcohols, converting alkenes to alcohols, esters to what? Alcohols. Right. Next, sodium aluminium hydride, it is reducing that what? Esters to alcohols. Normally sodium borohydride means it can't reduce, but it is sodium aluminium hydride. Borohydride do not reduce. Aluminium hydride reduce to alcohol, esters to alcohols. Right. Thank you. Next video we are going to solve some objective questions based on this.